I want you to freeze right where you are.
Yeah.
Like seriously, do not move a single muscle.
Not even a twitch.
Right, exactly. Whether you're sitting in a chair or walking down the street or gripping the steering wheel of your car right now, just pause and feel your physical position in space.
You feel grounded, right? Secure.
Yeah, you feel the weight of your body pressing into your seat or your shoes. But what if that invisible force holding you to the ground simply vanished?
Just completely gone.
Completely. Not weakened, not dialed down a little bit to make you feel light on your feet, but completely, totally disappeared for exactly 1 single second.
I mean, it sounds like a party trick, right? Or maybe just a minor inconvenience.
Yeah, you hear 1 second and you naturally think, well, how bad could that really be?
Exactly, because it is literally the blink of an eye. You would barely have time to process that anything had changed before it was over.
But from a physics standpoint.
Oh, from a physics standpoint, that single moment of zero gravity is enough to completely rewrite the rules of reality for, well, every single object, structure, and living thing on the planet.
And that is our mission for this deep dive.
Yeah.
We are unpacking a really fascinating thought experiment from our sources today that explores the physical, structural, and global consequences of a 1 second total loss of gravity.
It's a wild scenario.
It is. And we're going to strip away the Hollywood sci-fi myths and break down the actual terrifying physics of what would happen. Because that one seemingly harmless second would plunge the entire world into absolute chaos.
Total chaos.
So let's unpack this. I want to start with that very first fraction of a millisecond when the switch flips to zero.
Yeah, before we even look at the destruction, we have to understand the immediate physical reality of that exact moment.
Right.
Gravity is, it's the invisible tether holding everything together. It is constantly pulling every skyscraper, every ocean, and you, the listener, toward the center of the Earth.
So the moment that force disappears.
Anything that is not physically bolted deeply into the bedrock immediately begins to float.
Wait, I actually want to push back on the word flute for a second, because the source material makes a really interesting distinction about what this actually feels like.
Oh, right, the upward yank misconception.
Exactly. People usually imagine this scenario as a sudden, violent yank toward the sky, like you're being abducted by a UFO or something.
Yeah, like you're caught in a tractor beam.
Right. But it says you wouldn't feel a pull upward at all. You would feel pure weightlessness.
That is a crucial distinction.
So for exactly 1 second, sitting in your living room would feel identical to floating in the International Space Station.
Yeah, we are completely conditioned by pop culture to misunderstand anti-gravity.
100%.
Like when the gravity generator breaks in a sci-fi movie, everybody instantly flies into the ceiling at warp speed, as if they've been shot out of a cannon.
I mean, that's what we expect to see.
But the science of inertia paints a very different picture. Objects don't fly up. They simply continue moving in whatever direction they were already going.
I'm trying to picture this mechanically.
Yeah.
If I jump in the air right now, gravity immediately starts fighting me, right? It's pulling me back down.
Right, it's resisting your upward force.
So if gravity vanishes mid-jump, my legs have already imparted that upward force, but now there's nothing fighting back.
Exactly.
So I just keep floating up at the exact speed of my jump. But what if I'm just standing completely still on the sidewalk?
Well, if you are standing completely still, you would begin a very slow, almost peaceful upward drift.
Wait, really? Why?
This happens because the Earth is spinning.
Oh, wow. Okay.
Think about it. You are currently standing on a planet that is rotating at roughly 1,000 miles per hour at the equator.
Which is terrifying when you say it out loud.
It is. You are moving at that speed right now. Gravity is the only thing bending your path, so you follow the curve of the Earth. If you remove gravity, your inertia wants to keep you moving in a perfectly straight line.
Right, because an object in motion stays in motion.
Exactly. And because the Earth is curved, moving in a perfectly straight line means you slowly drift away from the curved surface of the ground.
Okay, that completely breaks my brain. The ground is essentially curving away from me while I travel straight.
That's a great way to put it.
So let me try an analogy here to see if I have the mechanics of inertia right. Let's take the listener driving their car.
Okay, classic scenario.
The car is moving forward at, let's say, 60 miles an hour. If gravity turns off, I'm assuming that moving car doesn't suddenly become an untethered, frictionless hovercraft shooting into the clouds.
No, it doesn't shoot up.
It just keeps moving forward, but suddenly it has absolutely zero traction with the asphalt.
Right. And taking that frictionless hovercraft idea even further, imagine what happens to the specific connection between the tire and the road. A car relies entirely on gravity to pull its mass downward, which forces the rubber of the tires to spread out and grip the microscopic bumps in the asphalt.
Right, that creates friction.
Exactly. When you hit the gas or turn the steering wheel, you are relying on that friction to dictate your direction.
So the millisecond gravity is gone.
That downward pressure vanishes. The tires relax. The friction drops to absolute zero.
So the steering wheel becomes completely useless.
Completely useless.
Spin it all the way to the left, but the car's just going to keep sliding forward through the air like an inch off the ground at whatever trajectory it had a millisecond ago.
It essentially becomes an unguided, multi-ton projectile.
Oh my gosh.
Millions of them, all over the world, simultaneously untethered from the road surface.
That is a terrifying image. But if we take that concept of individual cars and humans drifting based on their momentum, and we scale it up to the size of the planet, things get really bizarre.
Oh, planetary scale is where it gets super weird.
Let's look at the oceans. Because my sci-fi movie brain immediately pictures the entire Pacific Ocean exploding into the vacuum of space, like a giant water balloon popping.
Yeah, physics saves us from the Hollywood explosion once again here.
Thank goodness.
The oceans wouldn't instantly geyser into space because water has immense mass. And as we just discussed with the car, mass has inertia.
Right, it resists change.
Exactly. It takes a massive amount of force and a significant amount of time to accelerate billions of tons of water.
Wait, I need to challenge this because the source material mentions that the water near the surface would start lifting and separating into floating droplets.
Yes, that is true for the surface.
But the ocean is unimaginably heavy. How does a massive body of water just decide to become a droplet in a single second? Wouldn't the sheer crushing weight of the ocean prevent it from breaking apart that fast?
You are absolutely correct that the deep ocean wouldn't change much in 1 second. The immense pressure at the bottom of the ocean wouldn't vanish instantly because the water itself still has mass, and it takes time for pressure waves to travel.
That makes sense.
But the surface is a completely different story. At the very top layer, water molecules are governed by surface tension.
Right.
They want to cling to each other to form the most efficient shape, which is a sphere.
Because gravity isn't there to force them flat anymore.
Exactly. Without gravity flattening the ocean surface out, those top molecules would immediately start pulling together.
Ah, I see. So it's behaving exactly like the water floating out of a cup on a space station, forming those weird spherical flowing blobs.
Yep.
But it's happening on a planetary scale.
Yes, but it's a slow motion process. Over the course of just 1 second, you wouldn't see the entire ocean turn into bubbles.
So what would it look like?
You would see the surface violently ripple, bulge upward, and maybe the crests of waves would pinch out into large floating droplets. It's subtle, but bizarre.
Subtle but bizarre. I like that.
Yeah.
But if the water at the surface is reacting that quickly, what is happening to the air right above it?
Oh, the atmosphere.
Yeah, because gas is infinitely lighter than water. If gravity is no longer pinning the atmosphere down to the planet, do we all instantly suffocate?
No, you wouldn't suffocate because 1 second isn't enough time for the air to entirely escape into space.
Okay, good.
However, the atmosphere behaves like a giant compressed spring.
A compressed spring.
Yeah, gravity compresses the air molecules near the surface, which is why the air is thicker at sea level and thinner at the top of Mount Everest.
Oh, right, of course.
The moment you remove the compressive force of gravity, that spring instantly uncoils.
The air in front of my face right now would suddenly rush upward to fill the less dense space above it.
Exactly that. The entire atmosphere would rapidly expand outward.
Wow.
The sudden change in density would cause a massive, instantaneous drop in air pressure.
What would that feel like?
It would feel like instantly being teleported to the top of a mountain. Your ears would pop violently, and it would be incredibly disorienting.
Okay, so we've got bulging oceans and a rapidly expanding atmosphere. This brings us to things that rely on the air to function.
Like airplanes.
Like airplanes or birds. I'm fascinated by the mechanics of this. If a plane is, a miles-high flying wedge relying on specific physics, what actually happens to it?
Well, flight physics is a delicate balance of 4 forces. You have thrust, pushing forward, drag pulling back,
Right.
lift pushing up, and gravity pulling down. The wings of a commercial airliner are meticulously shaped to create a pressure difference in the air, generating thousands of pounds of upward lift.
Just fighting gravity the whole time.
Yes. This upward force is engineered to perfectly counteract the specific downward pull of gravity.
Oh, man. So if you remove the downward pull, but the jet engines are still firing and the wings are still slicing through the air, generating all that massive upward lift,
The plane doesn't just float.
it is actively launching itself upward.
Exactly. The careful balance of forces is instantly shattered. The aircraft would pitch violently. The pilots would have zero control because the aerodynamic profile the plane was built for no longer exists.
That's terrifying. And the same biological chaos applies to animals, right?
Definitely.
The sources point out that a bird in mid-flight flies by pushing its wings down against the air to fight gravity
So a bird flapping its wings would essentially just be throwing itself out of control.
because there's no gravity resisting the flap.
Right. Their natural biological balance fails. They would just tumble through the air, completely unable to orient themselves.
It highlights how every movement we make, whether it's engineered or biological, is basically a direct negotiation with gravity.
It really is.
It's a surreal picture.
Yeah.
You look out your window, and the water in a pond is bulging into bubbles, cars are drifting an inch off the road, and birds are cartwheeling sideways through the sky.
I mean, it almost sounds peaceful, like time has stopped.
Yeah, but I'm guessing it only looks peaceful for about half a second.
Precisely. Because the sudden unpredictability of the physics is what sets the stage for the true disaster.
Because the real catastrophe in this thought experiment isn't the departure of gravity.
No, it's not.
It's the exact moment it comes back, the violent snapback at the 1 second mark.
Yes. At precisely 1 second, that invisible force flips back on. The constant, unyielding downward pull instantly returns.
And everything that was floating, drifting, or tumbling is violently yanked back down to Earth.
Here's where it gets really terrifying. The sources point out that even if you only floated a tiny bit, the return of gravity is brutal.
Because you might think, oh, I only drifted up a few inches, I'll just land safely back on my feet.
Right. But the problem is orientation, isn't it?
Exactly.
When you are floating, your inner ear loses its sense of up and down. Without gravity, your body's natural orientation system just fails.
So you might have leaned slightly, or your feet might have drifted higher than your head.
And when gravity snaps back, you don't land, you fall.
So if you're lying in bed listening to this, you're fine. You float an inch, you drop an inch back onto your mattress.
Safe and sound.
But if you were walking down a flight of stairs,
You are completely vulnerable.
the variables are immense. Lying down is safe. Walking means you tumble awkwardly.
But imagine the window washers, construction workers on scaffolding,
Oh, wow.
someone climbing a ladder, a roofer.
Those small 1 second displacements become deadly falls when the force suddenly resumes.
And it isn't just people. We talked earlier about those cars traveling at high speeds, sliding across the highway with zero friction.
The 1 second mark for them has to be catastrophic.
It is the most immediate widespread danger, right?
Without a doubt. During that 1 second of frictionless sliding, those vehicles likely drifted slightly sideways. Or, out of sheer panic, the driver might have yanked the steering wheel.
Of course they would.
The moment gravity returns, the massive weight of the vehicle slams down onto the suspension, and the rubber tires instantly regain their violent gripping contact with the asphalt. And if the wheels are turned even slightly left to right while the car is sliding forward at 60 miles an hour,
The tire grips, but the momentum is going a different direction.
the car essentially trips over its own wheels.
Exactly. You would see hundreds of thousands of horrific rollovers and crashes on every highway on Earth in the exact same second.
And trains too.
Oh, yeah, trains that lifted a fraction of an inch off their tracks would come down misaligned and instantly derail. Air traffic, road traffic, rail traffic, all of it becomes a synchronized global disaster.
I want to dig into the cities themselves because the source material mentions immense structural stress. And this gave me a massive aha moment.
Oh, the buildings.
Yeah, I always thought of buildings as just heavy objects resting on the ground.
Yeah.
But they aren't, are they?
Not at all. A skyscraper is not just a stack of bricks. It is a highly engineered machine designed to handle tension and compression.
This is the part that blows my mind. The analogy that clicked for me is thinking of a skyscraper like an incredibly stiff spring.
Oh, okay, I like that.
If you take a heavy book and press it down on a metal spring, the spring compresses. That's a building under gravity.
Right.
Steel, the concrete, the foundation, it's all actively pushing back against the downward weight. If you suddenly remove the book, the spring aggressively uncoils.
That is a brilliant way to visualize it. When gravity vanishes, the millions of tons of downward force disappear, but the tension built into the steel and concrete is still there.
So the building physically stretches.
It tries to expand upward in that 1 second.
And then 1 second later, the heavy book is slammed back down onto the spring.
The slamming return of gravity is a planetary scale hammer blow.
Just devastating.
The building stretched, and now all that immense weight drops back onto the foundation in a fraction of a second.
Could they survive it?
Well-engineered, modern skyscrapers with earthquake tolerances might survive the flex, but older brick buildings, weak structures, and especially giant construction cranes.
Oh man, cranes.
Yeah, they would be subjected to a violent whipping force they were never designed to handle. Concrete shatters under sudden dynamic shock. Steel joints shear.
So you would see widespread structural collapses in every major city.
Absolutely.
And the most overwhelming part is that this is happening globally. It's not a localized earthquake. Every city, every ocean, every vehicle on the planet reacts simultaneously.
And emergency services would be completely paralyzed.
Because the police, the fire trucks, the ambulances, they would all be victims of the exact same physics glitch.
Humanity would survive. It is not an extinction-level event, but it would be an event of unprecedented chaos, massive structural failure, and millions of injuries all arriving at once.
Okay, I need a breather. Because picturing the structural spring of a building snapping is a very grim look at our infrastructure.
It's intense.
Let's do a physics reality check here so the listener doesn't spend the rest of the day looking nervously up at the ceiling. Based on our sources, can this actually happen?
You can cancel the plans for the anti-gravity bunker. The sources are definitive. Gravity doesn't operate like an electrical grid. You cannot flip a switch.
Right.
Gravity is an intrinsic property of mass. Specifically, the downward pull we experience is generated by the immense sheer mass of the Earth itself.
So to remove Earth's gravity, you essentially have to make the entire planet vanish from existence.
Or you would have to completely rewrite the foundational laws of physics that govern the universe, both of which are strictly in the realm of magic, not science.
That is a massive relief. But it makes me wonder, what does this all mean for us? If this scenario is physically impossible, what is the actual value of putting ourselves through this terrifying thought experiment?
The value lies in exposing an invisible constant in our lives. Right now, every second of every day, you are being pulled toward the center of the Earth at an acceleration of roughly 9.8 meters per second squared.
It is a relentless, inescapable force.
Yet you do not feel like you are being dragged down.
I don't. I mean, I'm sitting here right now and I just feel normal. That silent constant is totally invisible to my senses.
You feel normal because your biology is an evolutionary response to that exact downward pull.
That makes total sense.
Your skeletal structure, the density of your bones, the musculature in your legs, they all evolved over millions of years specifically to operate under that exact baseline pressure.
Even our organs, right?
Oh, absolutely. Your cardiovascular system is essentially a highly calibrated pump designed specifically to fight that silent constant, ensuring blood reaches your brain against the pull of the Earth.
We take it completely for granted because it is the baseline of our entire existence. We're so brilliantly adapted to this one specific rock floating in space.
Perfectly adapted.
Every archway we engineer, every airplane we design, every step we take relies on this silent partnership with Earth's mass.
We have never experienced life without that baseline. This one impossible second of zero gravity strips away the illusion that we are independent from our environment.
It really reveals the fragile mechanics of our world when you alter just one fundamental variable of our physical reality.
It really makes you appreciate the solid ground beneath your feet.
It does. But it also sparks a totally different idea for me. It builds on exactly what we're talking about, but it looks toward the future.
Oh, what's the idea?
If every single piece of our biology, our architecture, our fluid dynamics is evolved and designed specifically for an exact constant pull of 9.8 meters per second squared, what happens to us when we leave?
Ah, you mean long-term space colonization?
Yes. Think about it. What happens to humanity's physical evolution, our structural engineering, our very definition of up and down if we eventually colonize the moon or Mars?
That is a massive question.
Because these are places where that invisible constant is permanently altered for future generations. Mars has roughly a third of Earth's gravity. The moon was barely a sixth. If just 1 second of zero gravity on Earth causes total infrastructure collapse because our systems expect a specific tension, what does a lifetime or multiple generations of a completely different gravity do to the human body and society?
It is honestly one of the biggest hurdles for off-world settlement. Without that baseline pull, bone density drops significantly. Muscle mass atrophies.
The body just adapts to the new baseline.
Exactly. The fluid distribution in the body shifts entirely. A human born and raised on Mars might grow taller due to the lack of spinal compression, but their skeleton would be fundamentally weaker by Earth's standards.
They might never be able to visit the planet their ancestors came from because Earth's gravity would literally crush their joints and overwhelm their heart.
It forces us to ask a profound question. Are humans truly a multiplanetary species? Or are we permanently biologically tethered to the exact mass of this specific planet?
It changes everything. It means that stepping onto another world isn't just a change of scenery. It's a fundamental rewiring of the physics that made us human in the first place.
It's a heavy thought, no pun intended.
So I want you, the listener, to think about that today. Think about that invisible tether holding you down right now. You are perfectly designed for this exact moment, on this exact planet.
Don't take that structural tension for granted.
So unfreeze, go back to your walk or your drive, and keep questioning the invisible forces around you. We'll catch you on the next deep dive.